All right, so down my left-hand side, let's list these things. Sorry. There we go. P for pressure, V for volume, N for number of moles, R, we'll pick R from that table in just a second, and then T has to be in, what unit does the temperature have to be in? Temperature has to be in Kelvin, yeah, so we'll make sure we add 273 in just a sec. Okay, pressure is our atmospheres there, so 0.80 atmospheres. Volume, what's the volume of this gas? 2.0 liters. Okay, number of moles. Did they give me number of moles? No, that's what I'm looking for, so I'll call it question mark, and that's what I'll be solving for. All right, so for R, if we go look at the table that's on your sheet there, we need to find the value for R that deals with atmospheres, because they gave us our pressure in atmospheres. So what do they tell us the value for R is when you're dealing with atmospheres? You got it, yeah, 0.08206. It has a weird unit. Again, the only purpose of a constant unit like this is to make sure everything else cancels out appropriately. As long as you give me your answer in moles, we're good. And then for temperature, I'm going to say 20 plus 273 because I need a Kelvin temp. So I got everything there. I'm going to use PV equals nRT. This equation, I think it's helpful. If we know we're going to solve for moles, let's just go ahead and solve this for N. And then anytime you want to solve for N, you'll have it rearranged and ready to go. So it turns out number of moles is PV over RT. You can solve it. You can plug in and solve one step at a time too. Either way is fine. I'll do it this way. So then I'll say 0.8 times 2 on top. I know all my units are in good shape. Over 0.08201, or sorry, 206 times 293, all on the bottom there. All right, making sure everything stays down there in the denominator that's supposed to be in the denominator. And then we just calculate it. Okay, 0.06654. I'm looking at what's given. Looks like they were giving me mostly 2 sig figs. So to keep a reasonable number of sig figs, I'll call it 0.067 moles. And I'll be specific, I'll call it moles of helium if they give me the substance. It's going to be extra important on Monday to keep up with your substance because we'll have multiple substances mixed together or at the same time. So for most of what we do today, we'll focus on just one substance at a time, but it becomes more important on Monday to know what the substance is. And then if you're looking at questions like this and you're wondering, well, is that enough? I don't really know. That's a small number. Is that okay? Should I have got a big number? One thing that helps is to know that it's called the molar volume. So under standard conditions, if you have 1 mole of any gas, it's going to be about 22.4 liters. So 1 mole of gas, the particles are so far apart, that 1 mole of gas under standard conditions is about 22.4 liters. So then I can kind of compare my answer and say, okay, I've only got 2 liters, and I'm not even under standard, I've only got 0.8 atmospheres, so that's a low pressure. So it makes sense that if you just have 2 liters, you definitely wouldn't have more than a mole, because 1 mole under standard conditions is over 20 liters. So knowing that 1 mole is 22.4 liters of a gas under standard conditions helps me to kind of decide if my answer is reasonable or not. All right, so that's when they gave us moles. We just went with it there. I've got another one here I wanted just to practice with. The ideal gas equation was PV equals nRT. Was there anything about mass or grams in PV equals nRT? Not exactly, but we know how to go from grams to moles. So sometimes at the beginning or the end of a problem, you might have to interconvert between moles and grams. So that's why I've got this one on here for us to practice with. It says, what is the volume, and they want an answer in milliliters, we'll have to deal with that at the end, of a balloon filled with 0.45 grams of helium at a temperature of 23 degrees Celsius and a pressure of 2,280 millimeters of mercury. All right, well, let's just do the same thing we were doing before. We're doing ideal gas problems, so we're going to deal with PV equals nRT. List what we know, figure out what we're solving for, and then go from there. All right, did they tell me a pressure in the problem? What is it? All right, well, let's just stick with that. Remember, mmHg is the same thing as torr. So those two things are interchangeable. So that'll help me make sure I pick a good value for R. If I know I'm basically dealing with torr. You can call it mmHg or torr. Do they give me a volume? No, that's what they're solving. They want me to solve for, huh? Do they give me a number of moles? They gave me grams. You got it. So I'm just going to convert my grams to moles real quick. 0.45 grams. This is helium we're dealing with. What's the molar mass of helium? Is it 00? All right, thank you. I can't see that. It's 4 point something there. 4.00 grams. So I've got about a tenth of a mole or less, or something like that. 0.1125. It doesn't hurt to keep some extra digits at this point. .1125 moles of helium. All right, which R should I use this time? Should I use 0.08206 again? No, which one should I use? Yeah, the one that involves torr. What's the value for the, look at that box up, or the chart up on top. 6236, okay. As long as you're making sure all your other units match, you don't have to write that whole thing every time. Sometimes it's annoying to keep up with that, but that shows how the units work out. And then temperature, what's my Kelvin temp going to be? Is it 296? Is that what it would add up to? 23 plus 273. Yeah. All right, let's go from there. So we're going to use our equation, ideal gas equation, PV equals nRT. Whatever you like. If you like to plug in and solve from this point, you can. Or we could just go ahead and isolate volume. And then we'll have volume equals nRT over P. And then you're ready just to put those numbers in your calculator pretty much. 0.1125 times 62.36 times 296 all over my pressure of 2280. All right, let's see. What's the volume of this balloon going to be? Oh, go ahead. What was that? 997?
I got 9107.
Okay. What unit does the ideal gas equation give me? Liters. Because of that value for R, I mean the unit for R there, reminds us that that's going to give me liters. They didn't want my answer in liters. What did they want the answer in? They wanted it milliliters. So that means I'm just going to multiply times 1,000, move that decimal 3 places over. And so maybe
With sig figs, I'm thinking I should go with, well, the 0.45 grams kind of limits my sig figs, huh? So maybe I should call it 910 milliliters. I'm gonna have to go over here because I'm out of room. (910 milliliters). You could say milliliters of helium if you wanted to, or just milliliters, because that's the volume of the container in the end we're dealing with there. Anybody have any questions on that?